In the majestic Andes Mountains of South America, engineers are performing a feat that defies nature. They split sheer cliffs to build massive roads under conditions so extreme that any mistake can be fatal. The smallest error can send an entire project and its crew sliding straight into ravines hundreds of meters deep. Yet, through millimeter-level calculations and precisely controlled drilling and blasting, they persist. Heavy machines weighing hundreds of tons operate while clinging to steep slopes that would terrify even the most experienced driver. These winding roads reconnect regions that have been isolated for centuries, breathing new life into mountain communities. Are you curious how engineers can force a road to cling to near-vertical cliffs? Join us as we explore what comes next in the Andes. Building roads here is not just a transportation challenge. It is a direct confrontation with the planet's harshest terrain. Highways in Peru, Chile, and Bolivia are constructed at elevations of 3,000 to 4,500 meters. At these heights, the thin air reduces labor efficiency by up to 40%, making every movement a struggle. Weather conditions can shift from intense, skin-burning sunlight to blinding snowfall within just a few hours. In these projects, over 60% of the budget is spent on rock excavation, slope stabilization, and landslide prevention. Excavation requires massive power, but also surgical precision to avoid destabilizing the entire mountain. Sophisticated stabilization techniques, including giant steel anchors and netting, are the only thing keeping the road from sliding. Every meter of the road is preceded by intensive geological surveys to identify hidden faults in the rock. Water is the enemy. Without complex drainage systems to divert mountain runoff, the road would be washed away in a single season. When the cliffs become too steep to carve, massive bridges must be launched across valleys anchored into solid rock. Maintaining machinery at these altitudes is a nightmare. Cold temperatures and dust cause parts to fail twice as fast as normal. Strict safety protocols are the law. On these slopes, a simple trip can lead to a catastrophe, so every step is calculated. But the reward is worth the risk. For the first time, local produce can reach markets in hours instead of days. These roads are the arteries of economic growth, connecting the heart of the Andes to the rest of the world. As engineering advances, we are pushing further into the clouds, conquering terrain once thought impassable. The Andes will always be a challenge, but through human ingenuity, we are building paths to the future. Thanks for watching. Join us next time as we explore more engineering wonders. This is Mandarin Tech. The Andes Mountains present some of the most formidable engineering challenges on Earth. Building roads here requires a balance of precision, power, and deep respect for the terrain. Mountain roads in the Andes are usually built in two main stages, each designed to tackle different levels of geological complexity. The first stage follows the outer cliff face. Here, engineers cut the road directly into the mountain, creating a shelf-like path. To ensure safety, they stabilize the slope with heavy-duty anchors and retaining structures, protecting the roadway from unpredictable rockfalls. However, when the terrain becomes too steep or the geology too unstable, the construction strategy must shift. This marks the second stage, tunneling. By going through the mountain, the road bypasses the most dangerous exterior sections. This significantly reduces exposure to landslides and the extreme weather conditions common at these high altitudes. Now, we will take a much closer look at each specific step of building a road along a cliff, where the battle against gravity is most intense. The process begins at the very moment the mountainside is still completely untouched by human machinery. The first step is to precisely determine the road centerline. This blueprint is then marked directly onto the rock face to set construction boundaries. Based on this layout, drill holes are arranged according to complex, pre-calculated plans to ensure a clean break. Massive drills penetrate the stone, preparing the mountain for the controlled energy that will soon follow. Explosives are then carefully loaded in strictly controlled amounts. This isn't about destruction, it's about precision. The goal is to break the rock in sections, ensuring the overall stability of the mountain is not compromised after each blast. Once the rock has been loosened, the heavy machinery moves in. Excavators begin the grueling task of clearing the fragmented debris. These machines work tirelessly to pick up and remove the soil and stone, gradually clearing the construction surface. Efficiency is key. The material is loaded directly onto heavy-duty trucks positioned right along the edge of the road. These trucks transport the debris away, clearing the path for the next phase of grading and paving. Section by section, the mountain is tamed and a vital link is forged through one of the world's most difficult environments. This is the art of Andean engineering, turning impossible cliffs into the lifelines of the mountains. As the dust settles from the initial blasts, the massive task of logistics and earth-moving begins on the steep Andes cliffs. Debris is now ready for transport. These trucks operate continuously along temporary access roads, hauling debris to planned disposal areas. In certain sections, bulldozers push material directly down into the river or steep slopes below, shortening the time required for site clearance. Next, bulldozers take on the role of shaping the road, pushing away excess material and carving the mountainside into the initial roadbed. The blade is constantly adjusted to achieve the required slope and elevation, creating a stable surface for further operations. This cycle of drilling, blasting, excavating, and grading is repeated section by section until a continuous roadway takes shape. Behind the heavy machinery lies a complex web of logistics. Every liter of fuel and every part must be hauled up these slopes. Engineers and surveyors monitor every meter. Precision is key to ensuring the road remains firmly anchored to the dangerous cliff face. Weather remains a constant obstacle. High winds and sudden fog can halt progress in an instant in this high-altitude environment. Once the ground surface has been leveled and stabilized, it is compacted to provide a solid base for the final paving stage. A testament to human ingenuity and persistence, carving a path through the most formidable terrain on Earth. Phase 2 is complete. Welcome back. Today, we're diving into the critical phase of road construction, the delivery and preparation of the aggregate layers. The process begins with graded aggregate or crushed stone. It's delivered by heavy-duty trucks and dumped in strategic strips along the road alignment. Precision starts here, ensuring the right amount of material is placed exactly where it's needed for the base layers. Once the material is on site, wheel loaders move in to scoop and redistribute the stone evenly across the surface. This step prepares the material for the next construction layer, ensuring there are no large gaps or uneven piles. It's a balance of speed and precision to keep the construction timeline on track. After redistribution, motor graders take over. These machines are the masters of elevation and profile. They run along the route, spreading the aggregate into uniform windrows to manage the material flow. The operators adjust the elevation precisely according to the longitudinal and cross-sectional design profiles. When the road shape finally meets the required specifications, it's time to prepare for compaction. Water trucks spray the surface to control dust and create the ideal moisture conditions for the rollers. Proper moisture is key to achieving the maximum density required for a durable road. Now, the heavy hitters arrive. Vibratory and steel-wheeled rollers begin the critical task of compaction. The vibratory rollers use weight and oscillation to pack each layer tightly together. Steel-wheeled rollers follow up, ensuring a smooth and even finish across the entire width. They move in multiple overlapping passes to achieve the specified density throughout the structure. Consistency is vital. Every square inch must meet the engineering standards for load-bearing capacity. In curved sections or areas close to a cliff face, the work becomes even more technical and delicate. Graders continue to fine-tune the road edges and cross-slope to ensure proper drainage and safety. Every degree of the slope is checked against the design profile for optimal water runoff. Human expertise and precision machinery work in tandem to conquer the terrain. With the edges fine-tuned and density achieved, the base layer is now ready for the final surfacing. The result is a stable, well-drained foundation that will support the road for years to come. It's a symphony of engineering, teamwork, and heavy machinery working in harmony. Thank you for joining us on this look into road construction. Stay tuned for the next stage of the journey. Building the future, one layer at a time. See you next time. Building a road through the heart of the Andes is an engineering feat that demands absolute precision. This is a battle against nature itself. Next, heavy steamrollers move in continuous overlapping passes, compacting each layer of material to create a firm, uniform roadbed. In the narrowest sections where machines cannot reach, workers use hand-operated compactors to ensure every inch is dense and stable. As the road climbs higher, safety becomes paramount. Workers harness themselves to steep cliffs using pneumatic drills to break off unstable rock and secure the slope point by point. It is a dangerous dance between man and mountain, but necessary to build this legacy of connectivity high in the clouds, a lifeline in the sky. In the world of heavy civil engineering, safety isn't just a guideline, it's a lifeline. Today we look at the critical measures taken during hazardous road construction. Throughout the operation, all workers wear full personal protective equipment. This includes helmets, safety harnesses, masks, and gloves to minimize risks. Working in extremely hazardous terrain requires constant vigilance. Every piece of equipment is designed to protect lives in these precarious environments. Afterward, the entire cliff face is covered with a protective steel mesh. This massive installation helps secure loose rock fragments. This reduces the risk of dangerous rockfalls onto the roadway below, ensuring the long-term safety of the infrastructure. Once the slopes are secured, the focus shifts to the road surface itself. Next comes the precision-heavy asphalt paving stage. Before laying the main asphalt layer, workers spray a thin coat of liquid asphalt onto the roadbed to create proper bonding. This tack coat is essential for creating a strong bond between the structural layers of the road, preventing future delamination. This asphalt coat is then heated using gas burners, which is a critical step in the preparation process. The heat allows the solvent to evaporate, activating the asphalt's bonding properties and making it ready for the main layer. Now, the heaviest machinery takes the lead. The paver is the heart of this operation, moving with slow, calculated precision. During the asphalt laying stage, the paver moves slowly along the road, creating a perfectly level and durable surface. The machine continuously receives hot asphalt mix from dump trucks, which feed directly into the front hopper. This continuous feed is vital. If the paver stops, it can create ripples or weak spots in the final road surface. Immediately behind the paver, the compaction phase begins. Heavy rollers follow closely to ensure maximum density. Managing the temperature of the mix is crucial. Rolling must be completed before the asphalt cools below its workable range. Engineers monitor every step, from the mix temperature to the number of roller passes, ensuring the road lasts for decades. The result is a piece of infrastructure that stands strong against the elements and the weight of constant traffic. From the initial safety harnesses to the final layer of asphalt, every detail is engineered for safety and performance. Final inspections verify that the road meets all safety standards before it is opened to the public. When the barriers are finally removed, the mountain road becomes a safe lifeline for the local community. Modern road construction is a testament to human ingenuity and the unwavering commitment to safety in the most difficult conditions. Thank you for joining us on this deep dive into the engineering of our world. We'll see you on the next project. As the earthworks conclude, we enter the most critical phase of the Andean road construction, the laying of the asphalt surface. Precision is paramount here. The arrival of the paving train marks the beginning of a continuous, synchronized operation. The heated screed is the heart of the machine, keeping the asphalt in a workable state while spreading it into a smooth, continuous surface. Workers stand on both sides of the paver, closely monitoring the edges to ensure a seamless transition between the new road and the shoulder. They use shovels and hand rakes to correct any minor uneven areas or sections close to the rugged mountain road shoulder. The heat and smoke rising from the pavement indicate that the asphalt remains at a very high temperature, exceeding 300 degrees. Maintaining this temperature is vital, requiring the entire crew to work in close coordination and with precise timing. Some workers follow directly behind the paver to treat joints, gaps, or curved sections where the machine cannot maintain full control. The pace of both the paver and the supply trucks must remain steady to avoid any cold joints or interruptions in the layer. As the machine advances, a continuous strip of black, freshly laid asphalt gradually takes shape across the Andean landscape. This is the most visible stage in completing the mountain road, transforming a rough track into a modern highway. After the asphalt layer has been laid and sufficiently set, the focus shifts to surface quality and cleanliness. Workers use high-pressure sprayers to clean the surface and remove any remaining loose stones or excess construction material. The spray nozzles are moved evenly to ensure the roadway is clear and that the asphalt's bonding and surface quality are not affected. This meticulous cleaning ensures that the surface is ready for final markings and provides optimal grip for vehicles. Once the asphalt section is completed, the road surface gradually cools and becomes a solid, continuous layer. The cooling process clearly reveals the elegant curves that closely follow the contours of the mountainside. Beyond aesthetics, the integration of the asphalt with the mountain base ensures long-term structural integrity. What once took hours of grueling travel on dirt paths is now becoming a smooth, minutes-long journey. This road is more than just asphalt. It is a lifeline for remote communities and a testament to modern engineering. The precision of the crew and the power of the machinery have transformed this terrain forever. As the sun sets over the Andes, the newly paved road stands ready for the generations to come. Thank you for joining us on this journey through the peaks. High above the jagged peaks, a marvel of modern engineering emerges. From above, the winding road resembles a black ribbon draped across the cliff face. This marks the completion of an engineering work built in extremely harsh terrain, where the mountains test the limits of human ingenuity. In areas where the cliff face is almost vertical, there is no longer enough space to cut or widen the ground. Traditional methods simply fail. The solution is a suspended road system. Using reinforced concrete columns and prefabricated modules, the road floats along the mountain. Engineers have shifted to a vertical construction approach, utilizing the space below as load-bearing foundations. It begins with the bedrock. Large concrete columns are built directly onto the stone, acting as the primary structural skeleton. These columns support the entire roadway above, transferring the massive weight of traffic directly into the mountain itself. But getting materials here is a feat of its own. Due to the extreme terrain, conventional vehicles cannot deliver the necessary supplies. Instead, every ton of steel and concrete must be placed using specialized cranes or lowered from above into their exact positions. Precision is key. Every component must land exactly as designed, often in areas where a single mistake could be catastrophic. Once the columns are completed and have reached their required structural strength, the project enters its most visual phase. The road deck modules are installed section by section, much like assembling giant Lego blocks on the mountainside. Each module is prefabricated to standard dimensions, including steel girders and connection points, ensuring a perfect fit. This method significantly reduces on-site construction time, which is critical in environments where the weather can change in an instant. The assembly is a dance of heavy machinery and human skill, building a lifeline where none existed before. Every connection is checked and rechecked. At these heights, there is no room for error. Safety is the foundation of every action. Workers operating at height must always be secured with specialized safety harnesses. Their lives depend on the integrity of their equipment and their commitment to rigorous safety standards. As the road grows, so does the impact of this engineering triumph, connecting remote communities across once impassable terrain. This suspended road is more than just asphalt and concrete. It is a testament to what we can achieve when we refuse to be limited by geography. The result is a safe, stable, and stunning route that allows travelers to experience the mountain's beauty without fear. A black ribbon of progress draped across the ancient stones, marking a new era of connectivity. Engineering is the bridge between the impossible and the everyday. Thank you for joining us on this journey above the clouds. Built for the future, anchored in the present. This is the art of mountain engineering. In the heart of the Andes, engineers are redefining the limits of transportation. Building roads here isn't just a job, it's a battle against gravity and the elements. Welcome. Today, we're looking at the cutting-edge techniques used to construct stable roadways across some of the most challenging terrain on Earth. Traditionally, roads were carved directly into the cliff. But when the rock is too unstable or the slope too steep, engineers must look for alternative solutions. One such solution is building on supporting columns, elevating the road above the terrain to maintain stability without compromising the mountain's integrity. This modular approach requires absolute precision. Ground crews and engineering teams must work in perfect harmony to ensure every anchor is secure. Ground teams manage the logistics and work in close coordination with crane operators to precisely align each component. As the modules are locked onto the columns, the structure gradually forms a continuous roadway that follows the contours of the mountain. Once the structure is complete, the focus shifts to longevity. Finally, the road surface is finished and safety barriers and drainage systems are installed. These systems are essential to ensure long-term safety and durability, protecting the road from the heavy rains and seismic activity common in the Andes. This approach not only allows roads to cross cliffs that would otherwise be impossible to build on, but also significantly reduces the amount of rock excavation required. It represents a combination of modern structural engineering and an adaptive build with the terrain mindset, enabling infrastructure to exist sustainably. Even in the harshest mountain environments, these roads provide a lifeline for local communities and international trade alike. But as mentioned at the beginning, when neither carving the road into the cliff face nor building it on supporting columns is feasible, there is one final option. The next solution is to route the road directly through the mountain by constructing a tunnel system. But building underground brings a whole new set of challenges. Excavation is only half the battle. To keep the project moving, the project must be given its first breath, the ventilation system. At depths of hundreds of meters, pressure, dust, and heat can make the air toxic within minutes. Fresh air is the most critical resource. Engineers must create an artificial network to sustain life underground, ensuring a constant flow of oxygen and the removal of dangerous gases. From the construction center, vertical shafts are drilled up to the surface, creating the lungs of the tunnel system. Each of these shafts is about 4 to 6 meters wide and can reach depths of up to 200 meters, connecting the dark interior to the sky above. It's a feat of engineering that requires meticulous planning and constant monitoring to ensure the safety of every worker inside. The result is a secure and efficient passage that cuts travel times and bypasses the most dangerous mountain passes. Whether on columns or through the heart of the mountain, Andean engineering continues to bridge the gap between human ambition and the natural world. Thank you for joining us on this journey through the peaks. I'm your host, and we'll see you at the next summit. Deep beneath the Earth's crust, engineers are rewriting the rules of connectivity. This is the story of the mountain's lungs and the giants that breathe life into them. Welcome. Today we go inside one of the most complex infrastructure projects on the planet to see how we sustain life and progress miles underground. It begins with the air we breathe. Bringing in fresh air while expelling exhaust gases is a constant, high-stakes battle against the elements. Inside, sensors constantly monitor oxygen levels, temperature, and toxic gases, ensuring every breath taken by the crew is safe. Coordinating these powerful jet fans is essential to keep airflow steady, preventing the buildup of dangerous fumes in the deep sections. These ventilation shafts are built using the raised boring technique, where the drill head is operated from inside the tunnel and pushed upward. Moving toward the surface with near-perfect precision, these shafts are the vital link between the underworld and the sky above. Once completed, the entire network becomes the lungs of the project, a respiratory system of concrete and steel. This allows hundreds of workers to labor for hours beneath the mountain while still breathing the air of life from the outside world. Outside, the construction site is often shrouded in a haze of dust, a testament to the sheer volume of rock being displaced. While deep inside the mountain, a colossal machine is slowly being assembled, piece by massive piece. The tunnel boring machine, a true symbol of the modern infrastructure era, is the heart of this massive operation. Positioning this giant for its first operation is a highly complex process that demands absolute precision from every hand. It requires seamless coordination among hundreds of engineers, each managing a critical part of the puzzle. The entire system is delivered to the site through hundreds of specialized transport vehicles, a logistical feat in itself. Each vehicle carries modules weighing from dozens to hundreds of tons, demanding careful navigation of the terrain. From the supporting frame and control cabin to the intricate hydraulic systems, every component is vital. But the heaviest component is the cutter head, weighing over 1,500 tons and measuring nearly 15 meters in diameter. To accommodate this giant, auxiliary tunnels are widened, carving out the space needed for the machine to breathe and work. Every inch of progress is a testament to human ingenuity and the sheer force of our technological ambition. As the machine begins to turn, the mountain yields. What was once solid rock becomes a gateway to the future. The path through the mountain is long and difficult, but with the right air to breathe and the right tools in hand, no peak is unreachable. Thank you for watching. Welcome back. Today we delve into the heart of the mountain to witness the assembly of a mechanical marvel. The cavern is temporarily reinforced with steel and sprayed concrete to make room for these massive components in the confined space. Hundreds of industrial lamps pierce the darkness, revealing the scale of the task ahead. The modules are connected and aligned using laser sensors with a tolerance margin of no more than 5 millimeters. Powerful hydraulic jacks lift the cutter head into position, linking it step by step with the body and tail sections. Every movement follows a predetermined sequence, a choreographed dance of steel and pressure. Once fully assembled, the entire tunnel boring machine stretches nearly 100 meters long, the equivalent of a 30-story building laid on its side. Thousands of mechanical parts form a unified steel giant, ready to pierce through the solid heart of the mountain. This isn't just a machine, it's a mobile factory designed for the most punishing environments on Earth. From the central control cabin, the electrical, hydraulic, and pneumatic systems come alive in an instant. The mountain trembles slightly as the massive power of the machine is engaged. The tunnel boring machine begins to move. Weighing over 3,000 tons, it advances slowly yet powerfully. Thousands of mechanical components work in perfect harmony, a testament to modern engineering. At this stage, the cutter head is already buried deep in the rock, leading the charge into the unknown. While the front grinds, the rear section is still being assembled in the launch chamber, a continuous cycle of construction. This process requires precise coordination between power, water, air, and conveyor systems that must run without interruption. The conveyor systems work tirelessly, removing tons of rock every hour to clear the path forward. Every millimeter of progress is a victory of human ingenuity over the raw power of nature. Behind the machine, a massive logistical network ensures the steel giant never runs out of the resources it needs. Advanced air filtration and ventilation systems keep the confined space breathable amidst the dust and heat. Water management is critical, both for cooling the intense heat of friction and keeping the excavation site dry. Engineers monitor every vibration and pressure change, ensuring the safety of the crew and the mountain itself. One day, this dark passage will be a vital artery for transport, connecting worlds through the heart of the rock. Join us next time as we continue our exploration of the world's most incredible engineering projects. Thank you for watching. Deep beneath the surface, a marvel of engineering silently carves through the Earth's most stubborn foundations. These are tunnel boring machines, the mechanical titans that make our modern infrastructure possible, spanning miles through solid rock to connect our world. At the front, 4 massive hydraulic cylinders press the cutter head against the rock with up to 500 tons of force. 23 alloy discs spin with immense torque, crushing layers of rock as hard as steel. It's a battle of metal versus mountain. Each drilling cycle advances about 1.2 meters, taking roughly 30 minutes and repeating more than 50 times per shift. It is a slow, methodical advance, where every millimeter of progress is won through precision engineering and brute mechanical strength. The crushed rock is collected and carried out by an automated conveyor, while high-pressure water jets constantly cool and clean the cutter head. This debris, known as muck, must be continuously removed to keep the front of the machine clear for the next rotation. Once a cycle ends, the gripper shield pushes forward, hydraulic clamps lock onto the tunnel walls, and the next cycle begins. This rhythm, press, release, advance, drill, repeats endlessly, day and night, until the breakthrough is finally achieved. Behind the scenes, a TBM is a factory on wheels. A sophisticated erector arm places precast concrete segments to form the tunnel's lining. These massive rings are sealed and bolted, creating a structural shell that can withstand the crushing weight of the earth above for centuries. In monumental projects like Europe's Santa Lucia Tunnel or Switzerland's 57-kilometer Gotthard Base Tunnel, these machines operate 24 hours a day. Today, China leads this underground frontier with over 1,000 TBMs simultaneously carving the subways and railways of the future. Deep inside the mountain, the drilling has stopped, but the work is far from over. Engineers now carry measuring instruments, ensuring the tunnel's integrity. Technology has conquered the depths. Which nation's tunneling innovation impresses you the most? Share your thoughts below. Quietly enter the tunnel where every meter of concrete must prove its strength. This is where engineering meets absolute reliability. Every segment is a shield against the weight of the mountain. Pressure sensors and ground-penetrating radar scan the walls, detecting cracks thinner than a hair. Nothing escapes the digital eye of our monitoring systems. High-frequency ultrasound and 8K optical cameras inspect every bolt and seal to ensure flawless safety. Precision monitoring at the microscopic level ensures that no structural weakness goes unnoticed. In the control room, hundreds of real-time indicators track the tunnel's lungs. Every vital sign of the infrastructure is monitored 24/7 by a dedicated team of engineers. Jet fans, smoke sensors, drainage pumps, and a 10-megawatt backup power system are ready for any scenario. Reliability is built into every layer, from air circulation to emergency power. All tested under strict NFPA 502 and N505145 standards to guarantee international safety compliance. Every reading and vibration is recorded and analyzed until perfection is reached. Only then is the tunnel declared ready, a true symbol of precision and human resilience beneath the earth. So you've just joined us in exploring the entire process of building roads on cliffs, from clinging to the rock face and erecting concrete pillars to support these impossible pathways. The engineering required to bridge these gaps is nothing short of miraculous. To sections that require traversing the heart of the mountain, where the rock becomes our strongest ally. The information in this video has been compiled and filtered from various sources to bring you the full story. If you have any further questions, please feel free to leave a comment below. We love hearing your thoughts. Your engagement helps us dive deeper into the world of mega engineering projects. Stay tuned as we continue to explore the structures that define our modern world. And now goodbye, and see you in the next videos. Keep exploring and keep building. Background music swells to a lively finish,